Hello and welcome to Maski TV and Maski Miller Learning. Today again we are here with Teacher Tandy. I'm very sure that you guys are excited to continue with our journey of learning and studying. I am here to support you and to ensure that you understand the math. So today we have yet another topic that you guys are busy with in your term 3. I hope you have passed this, or if not, chill and we can do this together. So we are of course on geometry of 2D. So the 2D simple means two-dimensional shapes. So we are going to do that, grade 7s, and during this lesson we need to be able to identify the names of the triangles and also the names of quadrilaterals that we have. So do you know triangle? We talked about that. It's a shape that is drawn with 3 lines on it. I'm going to show you most of the examples and how they relate with one another. Also, we need to be able to identify or name the triangles or the quadrilaterals, which is the shapes we're talking about, using their sides, either parallel lines and perpendicular lines. I'm very sure that you guys have everything that you need to go through these lessons with us and make sure that you get to understand it. Okay, so let's do a quick recap and summary. With this, we are trying to say you have seen them before, but perhaps you've forgotten the definitions, right? So geometry of 2D shape is simple, just a polygon. So a polygon is just a shape that has a straight side, and it's classified with the classification based on angles and particular properties, which is what we are going to do the whole of today's. The properties of the 2D shapes, which we said is two-dimensional shapes, it's they are symmetrical. So shapes may have lines that are symmetrical, means that the line that cuts the shape in 2 different spaces or 2 equal spaces, which means symmetrical. We have angles that we do have. The interior angle of a triangle, each and every triangle have 3 angles. If we add them together, they always must give us 180 degrees. That is for any triangle. Then we have quadrilateral, which is a 4-sided figure. It's a figure that has 4 lines joined together. The vertices, which is their angles, are going to add up to 360 degrees. So that is what you guys need to know as properties. Again, we have diagonals. So diagonals is the lines that if you were given, for example, your triangle like that, and if I have lines that goes this way and another one that goes that way and another one that goes that way, that is the diagonal we are talking about. Is from that point to this point. We call that line a diagonal. And that one from that one is a diagonal, as well as when you have them into your quadrilaterals. So quadrilaterals can also have diagonals that when they divide, they make triangles and all those kind of things, right? For example, if you are given a triangle and you are told that in this triangle, you have 2 sides that are both equal 5 centimeters and the other one is 8 centimeters. That simple means that you have a particular triangle we call an isosceles triangle. So that's a different triangle which has names, which you will see as we go, and you know how to calculate them, right? So we do have types of triangles. In this case, we have equilateral triangles. In an equilateral triangles, all 3 angles are equals and they are all equals to 60 degrees, as well as the sides are equal. So if you want to know that this is an equilateral triangle, you can measure with a ruler your sides. They must be all equal. Or you can also measure your angles to be 60 degrees for you to be able to say this is an equilateral triangle. Then we have another one called isosceles triangle. An isosceles triangle have 2 equal sides. So the sides will be equal in length, and then we have 2 angles that are going to be equal. In most cases, we call them base angles, but that's not necessarily the case. So if you have 2 sides that are equal in a triangle and you have 2 angles that are equal, then that means that it's an isosceles triangle, right? We have a scalene triangle. This is a very a different name, but scalene just simply means that no side will be equal in that triangle, and all the angles will also be different. Then we have our special triangle called right-angled triangle. Right-angled triangle, it doesn't matter how it will have what it has, but the very important thing is that one of the angles must be 90 degrees. So that's what makes a right-angled triangle, special triangle. Then we have quadrilaterals, where one we have it as, I know you know about the square and the rectangle, so now you are learning about their properties, because with the square we know that all sides are equal and all angles are all equals to 90 degrees. Please bear that in mind. Then we have rectangle, and then with the rectangle, then we have opposite side, and that is what we have. So as we are seeing this all, we can then be able to see the relevancy of the diagrams that we have. So you see, for example, this is our rectangle, which is what I talked about. So these two sides are equal, and they're also parallel to one another, and the opposite sides are also equal and also parallel to one another. If you remember very well, when we were doing construction, I did say if you see one line like this once, it just simply means that the two sides are equal. But if the lines are like you given them and they are different, like now we have this one here and we have that one there, this is one line, this is two lines, that differently show that these two are not equal, but it shows that our side here equals to this side here, as well as the side which is here at the top, it's equal to the side at the bottom, as well as the parallel lines also indicate the similar thing. We talked about this, and you can see that is what is happening. So this is your rhombus. Your rhombus, you can see that is actually a particular square, which is literally the same. So you see, this one is our square, but this is our rhombus. But what happened is, with the square and the rhombus, the only common thing is that they all have the sides that are equal. All sides are equal, but the square have 90 degrees angle all over. So that is what is different. Then we have our special one, which we call trapezium. So all these two are called trapezium. Okay. So let's just quickly run through this together before we run on the questions that we have. So you can see here, for example, a triangle can be any of these shapes that are written, are shown here. So there's green shape, there's other shapes, blue, we have the pink, and we have the orange shapes. These are all triangles. But then we know that we talked about equilateral triangles, which we said all sides will be equal, and then their angles will also be equal, and they're all equals to 60 degrees. So you can see when I say they're equal, I put one line. If there was a difference one, I'll therefore put two lines if they were not equal. And that's how you classify that. Okay. Next one, we have the isosceles triangle. As I said, isosceles triangle will always have two sides that are equal, and that makes the two angles equal. This other one won't be equal to them. So when we label them, we show that the sides are, the angles are equal, which are opposite to the sides, right? And also the other one, it's not equal to them. That's isosceles. Then we have right-angled triangle, and our key is 90 degrees there. With a right-angled triangle, we need the 90 degrees to be there, and that's what helps us to understand and remember that a right-angled triangle have a 90 degrees as their angle, right? We have a scalene triangle. As we said, scalene triangle does not have equal side, so all these sides are not equal. So you see how I'm labeling them, it has different lines. So it's 1, 1, 2, 1, 2, 3, just to indicate that there's nothing that is equal. And if I had to do the same to the angles, I will have 1, and I have 1, 2, and I have 1, 2, 3. And some books will just have something like this with a line, and so on and so on. So you just need to know how you are showing out how it is equal and how it's done, right? Okay. Now we have the quadrilateral. So quadrilaterals, as I said, is just a four-sided figure. So you can see we have a polygon with four sides, that is A, B, C, D, right? It doesn't have to be equal at any point. That is just the quadrilateral. It's just like that. but there's names, or the one that have names, like a square. You can see a square has all sides equal. This one line here just show that all sides are equal and all angles equals 90 degrees, as well as the opposite sides are parallel. So you can say this is my parallel sign that is showing that AB is parallel to CD. And also I have a different one that shows that AC is parallel to BC. So you need to be able to look at that, because that's the differences that we have in this case. Okay, then we have rectangle as well. Rectangle have a similar characteristics as the square. The only difference is that not all sides are equal. Only a pair of a side will be equal. So AB will be equals to CD, and also AC will be equals to BD. So that's how it's different. Also, there are parallel lines. You see that AB is parallel to CD, and also AC is parallel to BD, right? Very easy. Okay, so I'm sure that you guys have seen that. We have parallelogram as well. So parallelogram have four-sided figure as well, but this one also, the only thing it doesn't have is a 90 degrees, but it does have the similar properties as the rectangle, where opposite sides are equal and parallel. So that is what it has. So you can see the properties is more or less of what we have talked about in the rectangle. Then we have a trapezium, which has one pair parallel. So that there's no equal sides at this point, unless it's a special trapezium, which is called isosceles trapezium, which will have an opposite sides that are equal. So then in this case, what we are saying is that we have opposite sides that are parallel for the trapezium, and this is how it looks. Okay, so that is the one property that it has. Then we have a rhombus. And a rhombus, as we said, is more like a square, but the only difference of a rhombus is that their angles are therefore not equals to 90, but the opposite angles are equal. They are not equals to 90, but they are equal. Then we have opposite sides that are equal and parallel, like what a square would have, and all sides will therefore be equal. You can see this one here. Right. Then we have one more special shape, which is a circle. We just decided to use a watch because that's a very best description of what a circle can look like. But you guys know what a circle is, and you know that it does not have any corner, it does not have any sides, does not have many of the things that the other two have, a square, the old triangle and the quadrilateral. But it has something special which we call the radius, and the radius is therefore called the diameter, which when we go on and on, you would learn about that. Okay. We do have some where you hear the word like pentagon. We decided to just put them here so you know what it means and how it looks like. We have pentagon, hexagon, and octagon. So in pentagon, what we know is that it has 5 lines. So 1, 2, 3, 4, 5 lines. And then hexagon also have like 6 sides. So you can just count them. It's 1, 2, 3, 4, 5, 6. Just like that. And also octagon have 8 sides. So that is what it has, which is different. And when you add their angles, they also differ from the angles that we said we add. We get 180 degrees. And the other one we said we get 360 degrees. Please bear in mind and remember those two, because I'm just telling you the total number of angles, what you will get as a value, but I didn't tell you what shape is that, because watch out. What I'm about to do now is to give you questions that can therefore help us to make you understand which one are we adding to 180 and which one are we going to get 360 if we add it together. So as we are busy doing this, I wanted to give you just a few minutes to digest and get everything together. Make sure that you understand all of them as we want to run and try to see if you guys can do this with us. So you can see the next activity is called Let's Work Together. So let's do it together and we see how we're going to classify. So as I give you a few minutes and I want you to try and do that without me. Classify those triangles. Tell me which triangle is which and why. How did you found that? See you right after the break. Yes, yes, yes. I'm very sure that you guys have done this together and you have popped it on the chart with the solutions of which one is which and how you're going to get it right. So let's start. Okay, we have number 1. Please put it on the chart. If you look at these triangles below, we are told and we are asked to say which triangle is this and how did we know that that triangle is what we are saying it is. So let's start with the first one, hoping that you have put the answers on the chart as I do it, because this we are doing it together. It's not an explanation, but it's a doing part, right? So let's see. Number 1, we have an angle 30, we have 40, we have 110. So when we have it like that, what it is that come to your mind according to all the explanations that we have been doing? Do you see, or do you recall? Can you remember what is it that is going to be? Which triangle is this? Of course, that triangle is going to be a scalene triangle. Remember we said a scalene triangle is a triangle that all sides are not going to be equal, and also that the angles are not going to be equal. So you can see we have 30 there, we have 40 here, and we have 110 there. So that simply shows that the angles are not equal and the sides are not equal. So this is going to be a scalene triangle, right? Now that's the first one. The second one we are given is, so we have an angle 35, an angle 55, and an angle 90 degrees. Yes, of course, that is a right-angled triangle, and our reference point is the angle of 90 degrees. So that is going to be right-angled triangle. So you need to just realize that property and you can be able to get to the solution. So that is your right-angled triangle. Are we together? Yes, of course we are. Okay. So we do have those triangles. Let's do this. So we have scalene triangle, we have a right-angled triangle, and then what else do we have? So number 3, we have an angle 75, and we also have an angle which is 45 degrees. And we have an angle which is 60 degrees. All these 3 angles are not equal, which means that all the sides are also not going to be equal. And that means we have yet another scalene triangle. So you're just going to write your angle scalene triangle. But how do you know and why are you saying that? Because you're going to say the definition is that, or the description is that their sides are not equal. So for example, number 1, you're going to say sides are not equal. So non-equal sides, non-equal sides, that can be 1. Or someone else can say non-equal angles, right? So that is 1 or 2. So you can use equal sides are not equal, or equal angles are not the same. So that's what makes it a scalene, right? But the second one, you can see, yes, you can call it a scalene triangle because all the angles are not equal. But this one is a special triangle because it has a 90 degrees on it. That's why it has a different name, right? Then we go on to number 4. You can see number 4, we're already given 2 sides that are equal. Just by showing these 2 lines, it shows that they are equals. And we're also given that 2 angles are equal. Which one is this? That is an isosceles triangle. So number 4 is actually an isosceles triangle. Isosceles. Okay. That is a spelling, guys. I forgot. Isosceles triangle, something like that. Let's go back. Why are we suffering? We have the name somewhere here, right? Where? Go, 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 go. There we are. Okay, so that is isosceles with 1 S. So that is isosceles triangle. There we are. Now we got it. Okay. Let's see. That was number 4. And number 5, we already see that we have all sides equal. So all the sides are given to be equal, and also all the angles are equal to 60 degrees. Which one is that? Yes, that is an equilateral triangle because it has equal everything. Equal sides, also equal angles. So that is equilateral triangle. Equilateral triangle. It has all the equal sides and it all have all the equal angles. So that's how you describe them. I'm very sure that by now you know which one will be 6. Without me saying anything, you can tell me which one is number 6. So number 6, you can see it all have different angles, right? You can see there's 60, there's 80, and there's 40. All the angles are not the same, which makes all the sides not being the same. So with that being said, that means number 6 is therefore going to be our scalene triangle. So these are the description of all the triangles that we have, and at this point you should be able to clarify them or classify them and be able to reason with the triangles. Say this one is not a right-angled triangle because it does not have 90 degrees, and so on and so on. So you should be able to justify why are you saying it's a right-angled triangle and why are you saying the other one is a right-angled triangle but not the other, right? So that's the first one. Then the second sums were about quadrilateral. Let's see if we can quickly do that together as well. We are also classifying the same. So in the quadrilateral, you can see that we have the first one. Can you recall which one is this? What is it looking like? It does look like a square, right? Yes, it is a square. Perfect. So that's a square. And remember we said, why are we saying it's a square? It's because all the angles will be equal to 90 degrees and the opposite side will be equal and parallel. So you can see those are our descriptions. Each and every pair or opposite sides will be equal and parallel. So that makes it a square, right? The second one, we have 90 degrees. But what is different from the square is that not all sides are equal as the square have. It's just that the opposite sides are now equal. You see the difference? Square, all sides are equal, while this second one, opposite sides are equal, and we call that a rectangle. So that is our rectangle. Now number 3, you can see it has one property that is the same as the square, which says all sides are equal. There's what we have, all the sides are equal, but the only difference therefore is that the angles are not 90 degrees. They are equal when opposite angles are equal, but they are not 90 degrees. So you need to just bear in mind that which one is that? That looks like it pulled away from the square. Yes, that is a rhombus. That is a rhombus. So please note that. And number 4, you can see that it's more like a rhombus, but it has one particular different or additional property, which is opposite sides are equal and also parallel. Opposite sides are equals and also parallel. That is going to be a parallelogram, right? So that is parallelogram. That is a parallelogram, right? Then we have this one. For most of us who have played, we know this one. Can you guys pop it on the chat? Let's see which one is it. Number 5, most of us should know that. That is a kite, right? If you remember how some of us have been creating it with a plastic and all those things. This is a kite. So we just write that one as a kite. And you just have to practice them, and you can know and you can be able to recognize them, right? Just by seeing. Number 6 is actually the rhombus. If you see it, you will see that number 6 is a rhombus. So when you look at this all the information that is given to us, it's actually have been here, you can see that is what is the rhombus is all about. There's a description, a definition, and also a diagram of how a rhombus look like. You can also see the parallelogram is there. You can also see there a trapezium that we just saw now. So we have our trapezium, which is the last one, right? And also, oh, this one have jumped somewhere. Let's see. Parallel. There we go. So that is our parallelogram. You can see that. So these are actually all our four-sided figure shape, which we call the quadrilaterals, right? So this is the one that we have, which is what we're talking about as quadrilaterals when we started like that, and also our triangles. So when someone says to you, classify the shapes, this is what you need to be able to know. You need to be able to check the length either by measuring it or by looking at what it is that is given that is equal, and also by looking at the angles. If you have equal angles, if the angles are 90 degrees, and so on and so forth. So when you are busy doing that, you will be able to identify all that need to be done. But before I forgot, most of the questions that I have used were literally taken from our today's textbook. And in today's textbook, page 35, you're able to see these things and how to classify it. We still have the platinum book as well. And it can also have many, many questions that can help you. We also have Spot On. And one of the important books that I have actually used when I was preparing there, it's Smart Kid. So Smart Kid is one of the best interactive book we have. What you do is when you are on the Smart Kit in your phone, laptop, whatsoever, you can actually be able to write your answer there, and it will give you an immediate solution into the Smart Kit. If you make a mistake, it will show a cross that this is not correct. So Smart Kit can help you actually to practice as you are using the other books to look at the definition, explanation, and all that. With the Smart Kit, you can learn then how to write this or how to identify what is it that you need to do. So you can look at these books, which is ours, Smart Kit, and I'm repeating, is the best one. And we do have today's, we do have Platinum as well as Spot On that can also help you to get to this question. But you can see there on my screen, as I'm saying, all these textbooks, we do have a support tool as well, which is additionally to the Maski TV videos that you have in Ask Maski on YouTube, where you can be able to ask anything and we can be able to assist you. You can also tune into the WhatsApp. So if you're not like a person who like being on screen, but you are listening to this lesson today and you're watching us every Monday in this lesson, you can also, during the course of the week, go to your WhatsApp, ask your parents, your sisters, anyone that can download Maski, or they can save our numbers 072 091 0388 and just ask Maski. When they say hi to Maski, Maski communicate like a human being. I guarantee you, you would never suffer in maths because Maski will give you the ways you need to know how to learn. So with that being said, I have just put the number here. You can jot that down. And our next lesson is going to still be on the geometry of 2D shape, but we will focus on similar and congruent 2D shapes. But I need you guys to keep on practicing, because guess what? If you're practicing, you will be somehow be perfect and you'll be able to understand and know what you need to know. With this being said, I believe you guys have learned and you will continue learning. If you did not get this one, keep on watching. Just subscribe so we can be able to notify you. Until next time, see you. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.